What is up, car and tech fans? Welcome back to another garage tinkering video. Today we're going to look at creating splash screens for a gauge, which you might want in your car or your sim or whatever it might be. But really, this video is about two things. One is creating splash screens and how we go about doing that. And secondly, and perhaps even more importantly, it's about feature enrichment and how something as simple as a splash screen can end up being quite a complex task with a number of things that are needed to work in it. And we're going to look at the difference between doing effective and worthwhile feature enrichment whilst avoiding scope creep. If you're not familiar with either of those terms, a quick 30-second overview is feature enrichment is when you add things that are worthwhile but also necessary to a feature. You enrich it, you make it better, but without it running away from you and adding lots of things on unnecessarily. And that's more scope creep. Scope creep is you saying, I'm going to build this thing. And partway through doing it, you go, oh, but I've got this other idea for something that would be awesome. And then you start to add that. And then you go, oh, but while I'm at it, I could do this other thing that's really awesome. And it runs away with you and you never end up at the finishing point. Feature enrichment is more about, let's get it to a point where it works and it's great. Then let's add something else on because it's necessary or because it adds a required utility to a feature. It'll all start to make more sense as I talk you through the process of how these splash screens that I've created for my gauges have gone from being very simple to being less simple, but without running away from me. So let's go through the process, how I went through it. I'll talk you through all of the changes that happened along the way. And whilst we're at it, we'll look at how we create awesome splash screens that work across all of the gauges on your car. This is where we start. We've got one of the screens for one of my gauges. It's an ST7701 LCD screen connected to an ESP32S3 driver board. We've got a voltage knockdown over here and the power supply for it. These two are unimportant, but we need the power. And currently, when we turn it on, it boots up and we get our screen, and that's it. The very keen-eyed of you might notice that when this thing actually starts up, there's a quick flash of white there. Unfortunately, there's nothing I can do about it. I've tried numerous things, but the way that these screens work is they initialize and start up before you can do even the first bit draw to the screen. So I can't flush it with a black background before it starts up. So I'm stuck with it, but I'm not going to cry about it. It's a very minor problem in the scope of things. So what is a splash screen and what's the purpose? Now, you've seen them. Whether you've seen them in a car, or whether you've seen them on a video game, or whether you've seen them on tons of different things, a splash screen is a loading screen. It's something that shows up before you go to your main display. And historically, they were used in order to give the application time to load things in the background. And we could use it for this to make sure that everything is loaded properly before we actually show the display. But the packages we run on these things are so small and efficient. They're up and running in a fraction of a second. So it's not necessary from a utility perspective. We're doing this purely on an aesthetic perspective. If you look at the dashboard of a modern car like the new Nissan Z, they often put these splash screens up just as a way of being like, hey, you're in the car, something cool is about to happen. So that's the reason we're doing it. We're doing it purely for aesthetics. Now we're going to do a really simple one that literally just shows an image and then fades away to the screen. But because I've got a 350Z, and because I've got three little gauges and then the big gauge in front of me, my design is going to be to show 3, 5, 0 in the three small gauges, and then I'm going to show a big Z right in the middle of the driver's one in front of me, so it'll kind of flow between all four of the screens. So let's kick all this off with iteration 1, the most basic splash screen that we can think of, which is going to be putting the logo on the screen and then transitioning with a fade to the actual gauge. Creating a really basic splash screen is pretty simple. This is how we do it in a code format. All of this code is available on the repos, which are listed below. So if you want to grab this code from there and take a better look at it, you can. But we've created a new kind of screen called the splash screen. We go right down to the bottom to our UI initialization function here, make UI. We're making the splash screen. And the splash screen here is a null object. It's got a background color set to it, which is black. It's got an icon 5, which I'll show you in a moment. That icon is an image. If you want to know about how we use images to create glyphs and things like what we're going to be using on this display, you can check out the video here where I talk you through using glyphs, sprites, and icons in LVGL like this. We align it in the center. I recolor it to white and I make it a cover opacity, which is like 100% opacity. So this is the simplicity of the design. Like I said, I'm going for a 3, 5, and 0 in these 3 gauges. And this gauge we're looking at right now is the middle one. So it's got a 5 in it. So we make our splash screen. Then when we go to the setup function, at the very end, after everything's initialized, we start splash. And I've kept this the simplest form possible. It's doing a load animation. So it loads the splash screen and it fades in and it takes 1 second. It's not delayed by anything, and false means delete the previous screen that you are moving away from. We're not moving away from a screen, so that's false. And then there's another load animation. These screens have got 2 modes on them, track mode and daily mode, which is saved in memory. So this is just basically saying if track mode is activated, then the next screen we're going to load is track mode. Otherwise, we're going to load the daily screen. Again, it's going to be a fade. It's going to take 1 second, but it's going to wait 3 seconds before it does it. And just by putting these 2 directly next to each other, they both run immediately as soon as the function starts. But the top one will run straight away and last a second. This one will wait 3 seconds before it loads. So you'll get 1 second of animation in, 2 seconds of it showing, and then 1 second of it animating to the new screen. That's it. That's the simplest version of the splash screen. Let's have a look what that actually looks like on the gauge when we start it up. Right, so that's the simplest version. You'll notice a mistake. When it starts up, it doesn't fade in. It jumped straight to the 5. And that's because there's no screen for it to fade from to. And it's trying to fade from nothing to a new screen, which means it doesn't fade, it immediately jumps. Also, the crossfade, I don't like that. I don't like how it goes from one straight to the other. So our first bit of feature enrichment is to make the appearance of the logo feel less jarring. So we're going to start with a black screen, fade into the splash screen, then fade that back out to black, and then the black away to the gauge. And it'll make the screen and the whole transition process feel a lot more pleasant rather than that jump and then a transition straight into the gauge. It'll all feel a lot nicer. We do that by adding in an additional screen. So there's the splash screen itself, but then there's the startup screen. That's what I decided to call it. So alongside having this splash screen, there's lots of extra challenge. Alongside having the splash screen, we've also got the startup screen, and that's just a black startup screen. So it's the starting point, kind of like you imagine the layer. It's just a black background, and then the splash screen loads on top of that. What I felt was a good idea was to pull it away from the initialization that does with all the UI, because I try to think of it separate to the UI. Instead, when we've got our screen initialization here, after we've initialized all the stuff for the panel display, which allows us to draw onto these boards, we just create the startup screen here as an active screen. And then we set that to be black and to have a full black background opacity. So we'll get that little white flick because, like I say, we can't get rid of that. But then this screen, a plain black screen, will load immediately. Then we had to make a little bit of a change to the loading order, which seems more complicated than it is. So we kept in the animation that goes to the splash screen and it fades in for 1 second with no delay. So straight away it loads that crossfade, but now because it's crossfading from a screen rather than from nothing, we'll actually get the fade in animation. But then once we've got the splash screen up, instead of just crossfading straight to the gauge itself, we want to go from the screen back to black and then to the screen. And whilst doing that, we want to delete the screens that we're never going to use again and unload them from memory, which is why it's done with this timer. It just helps manage that a little bit better. So we create an instance of this timer and we called it exit timer in order to attach this repeat count once. So we want to make this timer object run just the once, otherwise it gets caught in a loop and runs forever. It's going to pull in this changing load screen function, going to wait 3.5 seconds before it actually starts it, and it's going to pass it startup screen as the screen that we're going to load next. So that's what this changing loading screen function does. It'll accept a screen that says, what's the next screen that we're going to load? So inside this change loading screen, we've got a complete false flag. We'll see that in a second. And then we pass in the timer. This is like the user data. So we pull the next screen out of that user data, so we know what is the next screen that we're loading to. And then we load to that next screen with a 1-second transition, and we delete the previous instance. So this is going to enter here. It's going to say, right, okay, we're going to go to the next screen, which is the startup screen. We're currently on the splash screen. And so we're moving away from the splash screen to the startup screen again. And subsequently, we're able to delete the splash screen. But if it's not complete, which it isn't the first time this runs, create another instance of this. So we just recursively loop and come back into the same function. And we're going to go to either, depending on if track mode is set, because these screens have got a track mode and a daily mode, go either to the track screen or to the daily screen. And then that comes back into this function again for a second time after now complete is set to true. It now has either track screen or daily screen in as next screen. Then it loads to that screen after there. So what these timings will be is there'll be a 1-second load in, 2.5 seconds of showing the thing on the screen. It'll then take 1 second to load that out. And then the second time it comes through, it's going to animate us to either the track screen or the daily screen. And then the true delete will delete the startup screen. Hopefully that all makes sense. It just means we can move through the two different screens and then just delete them as they go, as we move away from them for the last time. So that all together looks like this. Go, nice fade in, 2.5 seconds, fade out, 1 second, fade across. Show you that again one more time. So wait, fade in, 2.5 seconds, fade to black, 1 second, fade across. Lovely. If that's all we cared about, making a single splash screen with a logo that fades in and out, you could stop there. But we have 3 little screens to put this on. So let's do it on a second screen, and I'll show you feature enrichment requirement number 2. So I've added an additional screen. This is the weather gauge that I'm putting into my car. It has the number 3 on it. There is obviously a third screen, but I broke it. So we're down to 2. It's perfectly fine, just use 2 for the purpose of this demonstration. So if we boot those up, on they come. And you might have spotted the concern of mine there. They look great, but this one started ever so slightly before this one. We're talking fractions of a second. Let's see if we can get it to do again. There, you saw the 5 come up ever so slightly faster. So feature enrichment requirement number 2 is to get these to start at exactly the same time somehow. The problem we're having here is they're both getting power, and you can't guarantee that each one is going to take the exact amount of time to a fraction of a second to get to that initialization of the startup screen. So if one happens even a 1/10 of a second before the other, it's noticeable. Now, a lot of you would go, it's close enough, it's fine. But if you're anything like me, that fraction of a second is enough for you to want to fix it. So how do we do it? And what we need to do is have some kind of flag, and it's a go flag that all of the devices can get at exactly the same time and make sure they start that splash screen animation process at exactly the same time, and it gets rid of that slight delay between them all. When I first thought about through the ways of doing this, The initial thought was to get one of the screens to send out an ESP now message to the other two screens to say, go, and then they'll all run at the same time. But the problem is you introduce extra errors there because one is going to start, but then it's going to start at the same time as sending a message, and the other two then have to wait for the message to be received, to be processed, and then start. So chances are, if you do that, the one screen that is sending out the message to the other two is going to be ahead because it knows to do it. And the only way you could then get them all in line would be to delay one of them, and it would all be a little bit finicky because you don't know how long the message is going to take to send and process them. So we already have a bunch of additional ESP32 devices that we're using to control these boards in the shape of this thing, which you might have seen if you've looked at my video about switching displays. If not, you can go and take a look at exactly what this is. It's basically going to be using the OEM buttons of my 350Z on the side of the driver's console to control these gauges and switch between screens and stuff. But this thing already has ESP now running on it. It is all ready to set up to broadcast to all of these displays, and it receives power at the same time of all of these displays. So I can use this to send a go message to all three displays. They'll all receive that go message at exactly the same time, and that should synchronize everything. So let's code that. It's all relatively trivial, but if we start with the common file, which is the one that I use that shares information between both the remote control and the screens, I've added a new type of flag for my ESP now data sources. So I've got flag startup, which is just basically saying it's a startup flag. And then we added a new super simple structure here because ESP now requires structures to send data back and forth, and it's just the startup structure, and it's just the flag. So that's all it's doing. It's just going to send just the flag. And that's all we need from that. In the remote control code, we've just created an instance of that startup data. And then when the Wi-Fi has been set up, we've done this in a way that is completely not the way to do it. We set up the ESP now, we add all of the addresses correctly, then we wait for 3 seconds. This is just as a test purpose. It's not how we're going to do it. Don't come at me for putting a delay in my setup function, but we'll set the instance of that object to have that flag, that startup flag, and then we'll send it out to the 3 devices all at once. And obviously, as we add more gauges, they'll all go in here. So it all gets sent to everything on the network at once. And because we're not listening for replies, we can just send them all, and it basically happened on all of them instantaneously. What that means is on our actual gauges themselves, we can just add an extra kind of loading flag. So we'll have this bool startup ready. So we're saying, has the startup ready been sent? In our loop at the very bottom, we'll run the continued check for that startup ready flag coming through from ESP now. And if it is set, then set it back to false. And then we've got the start splash, which will run the splash screen when that is found. And then very lastly, in the ESP now receiver code, we have a new case. And if the startup is received, then the startup ready is true, which means it picks it up in the loop and everything fires and starts. So all it needs to do is pass the flag, and all 3 devices should boot up at exactly the same time. So here's what this one looks like. So now not only do we have our 2 screens, we have the remote control device, which 3 seconds after booting up will send out the pulse. Those 3 seconds are really just to ensure that these 2 are completely awake and initialized before sending out the pulse, which is not, like I say, the way that we'll do it in practice, but for now. So let's give everything power and simulate what it would be like when all 3 of these get power at the same time. So gone, we expect 1, 2, 3, everything starts up perfectly in sync, which is what we like to see. But by doing this, we add in a couple of cases where it can all break, which wouldn't be there if we hadn't put in this startup pulse. So let's break it and see what we have to fix. I think the art of this QA side of doing things is you think to yourself, what if? So what if the power to one of these screens dipped out? Let's take the one on the right and just unplug it. Boop. Okay, so the power for some reason has disconnected and then it's reconnected again. It's going to go and it's going to sit to that black screen, but the startup pulse will never come from here. So it's just going to sit there forever. That's a problem. That's problem number one. Then there's problem number two. What if this device, the one the remote control, was to power off and power on again? It would come on, it would take 3 seconds, reinitialize, and then send out a startup pulse again. And these are going to try and run even though they shouldn't. So let's just reboot this and give it 3 seconds. And they're going to crash. So that's a problem. Additionally, if we unplug this and reboot everything, so if the screens start up together at the start, but the remote doesn't, these will never initialize because they're waiting for that startup pulse. So that's another condition we've got to check for at this point in time as well. So that's 3 things. What if the screens start up and the remote doesn't? What if a screen reboots after startup and the remote is already on? And what if the remote restarts and sends a secondary pulse out? The pulse one, the final one, if the remote restarts, is a really easy fix. All we need to do is come into our gauges, add an additional startup flag. So we'll do bool startup complete is equal to false. Then at the very bottom here, if startup ready and startup complete isn't complete, and then we can just set startup complete is equal to true. And because this one never resets to false, this start splash function will only ever run the once unless the device restarts. So the remote control restarting won't redo the start splash animation and won't cause everything to break. And the reason it breaks is because it tries to load the animation, which means it tries to load screens into that animation function, but those screens have been deleted. So they don't exist and it all fails. So that'll cure that problem. That one's nice and easy. The other 2 conditions, what happens if one restarts or if the remote control never initializes, we can just do by having a timeout fallback and make it really simple. So if it doesn't receive the startup pulse after a certain amount of time, just start yourself up. So in my common file, I've just added a definition, startup override timer. So how long is it going to wait until it starts up of its own volition? And then in the gauges, what we've added to both of them is at the bottom of the setup, we'll run another one of those timers. So we've done a couple of these timers with the animations before, and it'll just repeat the once. It'll do the force splash function after that amount of time. So we set it to 5 seconds and pass in the startup screen. So we'll basically force start that startup animation. And then we've got it here. So if it isn't already complete. So again, we're just making sure that that completion hasn't already happened and we're resending this force animation. Because this timer is going to fire after 5 seconds after startup, one way or the other. Doesn't matter if it's received the pulse, this is still going to fire. So we need to put that check around there. So it'll actually only start the splash if it hasn't already started. Otherwise, we're just going to introduce the same problem that we just removed. And that should fix both of the other problems. The issue of what happens when the screens start, but the remote doesn't, and what happens if a screen reboots and the remote is already up and running. So let's take a look at that. Oh yeah, plus we need to add startup complete is equal to true in this little force as well. So if it's forced itself to start up, then that startup complete tag is also done rather than it having to, be done by the loop. So we have 3 conditions we can make sure work. What if the screens start up, but the remote control doesn't? So they should do a count of 3, 4, 5, and then start themselves, which they do. That's their fallback. Then what if the remote control turns on, but these have already started up? It was causing them to do a panic reset, so it should now not do that. 1, 2, 3. Good. And then what if one of the screens turns off for some reason? Just turn that one off. And then turn it back on. It should 1, 2, 3, 4, 5 and just reset itself. So we end up back at the spot that we want to be. So all of those edge cases are now covered, and this is a much more kind of robust solution. A number of hours have passed, and now it's dark and in the evening. So this feels like a good place to draw the line with putting on these splash screens. Otherwise, we're going to start getting into the realms of scope creep. Like I said from the start, the difference between scope creep and feature enhancement is that scope creep is kind of like the want, whereas feature enhancement is like the need. You just want to make sure that you're building the things that you have to build in each iteration, rather than things you just necessarily want to. It just prevents the scope of the project running away with you too much. Now, there is one additional thing that I do want to do, but I'm not going to do it tonight because it's date night and I don't want to be sat here coding for much longer. So it's that 3-second delay when the remote comes online. I don't want it to just sit, wait 3 seconds, and then send the pulse. What we're going to do is add a check in there instead of that 3-second delay, where we send a request to each one of the gauges, and we do it in a little loop, and we then listen for its online status. And if all 3 of them come back really quickly and say, I'm online, then we just send the startup code. So it prevents us having to wait for those 3 seconds. Instead, we can just see as soon as all 3 of them are online and then send that message. Obviously, it means that if, like in this instance, one of my gauges is missing, so only 2 of the 3 will come back online. So that pulse will never get sent, and the timeout is what is going to end up turning these screens on. But that's fine. It's in the case that there is one missing, then that is probably a good way of handling that as an error. So yeah, there we go. Building splash screens, simple splash screens. Obviously, we can start in the future looking at fancy animated ones that take a lot more work. But for something simple like this, putting 350 on those 3 screens and then the Z on the big screen in front of me, this works perfectly as a solution. Everything's timed correctly. There's resilience integrated if things accidentally, power out or restart or surge or whatever it might be. We cover a load of the bases to ensure that these things are robustly designed where possible. The latest versions of these gauges are up on my repo. If you want to get a link to that, they are down below. So if you want to play with this code and use it yourself, you can do. There are a couple of dependency files that you will need, but all the information is actually on the repos themselves. If you fancy a little challenge, maybe try doing that online request yourself, where the delay 3000 is on the remote control. See how you get on. It's an interesting little problem that you could try and solve whilst getting a bit more to grips with ESP now. Otherwise, I hope that's helped if you've considered doing splash screens on your gauges, and if you want to make sure that, like I say, they're robust and they handle a lot of different use cases and scenarios where things might fail. Are they over-engineered, considering really all those catch cases have to be in there just because I wanted them to all start up synchronously? Maybe, but now they all start up synchronously, and it's going to look real good when it's in the car, and it's not going to bug me every time I turn the car on and one starts slightly after the other. Really good for my mental health. Anyway, if you've got any questions or comments, make sure that you throw them down below. I try to read everything, but it's getting a little chaotic now because we've just gone north of 10,000 subscribers, 5-figure club. So thank you very much for everybody's support on growing this channel. It's been incredible over the last few weeks in particular. And if you want to discuss this stuff anymore, we've got a Discord channel. You're very welcome to come in and talk about this stuff or your ongoing projects, or, discuss problems you might be having. There's lots of really cool, helpful people in there now. Anyway, that's it for this one. Whatever you do with the rest of your day, folks, have a wicked one, and I'll see you next Wednesday, 2 p.m. Take it easy, peeps. Bye-bye.